I'm light as a feather, yet the strongest man can't hold me for much more than a minute.
Breath.
Your breath. What are yesterday falls today and tomorrow's in the middle? Like some messed up world.
I don't know.
Yesterday falls today and tomorrow's in the middle. Addiction. Addiction.
Oh my God.
That one
You're evil sometimes. Right? What do you guys want to make today?
Can we have off day?
Huh?
Can we have an off day?
Can I make a program that does something?
We don't get an off day. But we're going to review our syntax. So we're going to make something.
Oh.
Right? Because class objects represent things that we can make. Like do so. You want to make a pie?
Ooh. Apple pie, cranberry pie.
Everyone says that's so cool, and then I tell you my last class, you know what we made? We made bread.
Oh.
Today we're going to
Okay.
make a pie.
Awesome.
Right? And so when I make,
Yesterday was pie day. What?
I know, today's not pie day, but we're going to make a pie because we missed pie day, right? And maybe you didn't get a pie. So I had some pizza pie yesterday. When we make objects, right, when we're thinking about objects, there's a couple things we have to do. Think about what are our behaviors, what are our attributes, and once I have those, right, we have to make the blueprint, which is our class, right? And so, right, if I think of the attributes, it's always good to start with your attributes first, right? Attributes of pie, what are some attributes?
Crust.
What?
Wait.
Crust type?
Yeah.
Amount of sugar?
Filling.
Right? Filling,
Fruit type or whatever.
right? Such a filling type, right? Fruit, whatever. Size. There's probably more, right?
I'm pretty sure.
That's good enough though, because I don't want to keep writing.
And pie, is it like a chicken pot pie or is it like a fruit pie? Or a
Well, apparently this is attributes of maybe like a fruit pie. Although the filling type, right, you can still have a normal crust, and the filling type could be chicken pot. Right? I don't know. Right, so to create the blueprint, the keyword we use is what?
Class.
Good. And the name of our class is?
Type of pie.
Right, so pie.
Oh.
Right? Pie becomes a type, right? It's a user-defined type that we can now use. Right? Get our closing curly and our semicolon. Right? This is harder for you to do on the whiteboard, but usually you always want to start with your attributes and then work on your behaviors. Right? So I'm going to leave some white space, and hopefully I'll leave enough white space.
Private.
Right? Good, because attributes should always be what?
Private.
Private. Right? And then I have 3 things, right? Now, this is great for coming up with the attributes, but we need them to be, right, types, variables in C++, right? So what type could a crust be?
Care.
Right, could be a char. Anything else?
Int.
String. Could be an int.
Could be, yeah.
Right? Filling probably all the same 3 things. Right? And size would probably be what?
Integer.
Could be a double.
Yeah.
Or an int. Or a string. Right? Probably all of those, right? And so your goal is to pick what you think works the best for your blueprint. Right? We'll do crust type, we'll do characters, right? So char, crust type. I don't know.
Well, you forgot public.
I'm writing in the wrong spot.
Oh, true.
How dare you?
Down here where it says private. Char, crust type, what? Underscore?
Yep.
All right. Char, all right, filling type. Underscore, everyone good there?
Mm-hmm.
And then I have size, right? We'll just say int size. No half pies. Right? I don't know.
Could we, because I kind of want to see what you do with it. Could we add a bool type just so that I could see us turn on, like if it's hot or cold or full or whole or slice or something?
Piece?
Like serving size?
Or just like a piece?
Or
The boolean wouldn't be a serving size. I'm trying to think of one that will fit in our.
Because if you're trying to sell a pie, someone orders a whole pie, or someone comes in for lunch and orders a
Right, but that's
slice.
just size. Yeah, cooked. How about cooked?
Or
Yeah.
to go or here or
Is my
something.
pie cooked or
Yeah,
not?
there are some pies you don't
that?
need to cook.
Yeah. I just want to see what you do with it.
You're a coward if you don't eat a full pie.
Right, exactly, right. So only full time. So bool, cooked, underscore. All right, there we go. We
Thank
have
you.
4 attributes. I'm not gonna write all the methods, right, the functions for all those, because.
I just want to see it be on or off.
So, everybody, here's my pi, right? We need an interface, right? The way that we're going to use our attributes is via functions, right? And that's our interface, which goes in our public section. Okay. So apparently I'm gonna work with the bool, right? Cooked. Right, I can work with any of these, but I can't write that much on the board. I'll get carpal tunnel. So we're only gonna do that. Right, so we have public, right? So let's talk about functions that are made specifically for attributes, right? They're called mutators and
Behavior? No.
accessors, right? Mutators and accessors. They're always named the same. They always do the same thing, right? So we're trying to get that pattern down. Right, and in today's lab, you'll do more with that pattern as well, right? So let's write the accessor. Accessors are named after the attribute. So my attribute is bool cooked underscore. My accessor is bool cooked, right, parentheses. Right? That's my accessor. Right? Its goal is to, right, access, right, the value of that attribute. Its goal is to access and give you the value of that attribute, right? We also have, right, a mutator for it, right? Mutators are always void, then the word set, and then underscore the name of your attribute. If my attribute is called cooked, then it's called set what?
Cooked.
Cooked, right? Mutators change the attribute, which means they have to take data in because they change the attribute. Agreed? Right, so I need something in here because this is going to change the attribute. Right, we call that a parameter, good.
True or
right?
false?
We make it really easy because it's just called the same as what I'm doing here, right? Set cooked is what type? Bool, which means my parameter is a Boolean, right? And we just call it cooked, right? We leave off the underscore because the underscore is the attribute, but the goal is to take the parameter and store it into my what? Attribute. Make sense? Right? And then, since we're working with cooked, let's add just a regular member function called void, right, cooked, cooked type. Right? Sound good? Right? This is an accessor. Accessors always look the same. This is a mutator. Right? Mutators always look the same. Right? The other thing is just a function, right? It's just a behavior of my class. Make sense a little bit? Right? Obviously, I would have more, but that's all I'm going to write for now. Once I've done that, what's my next step?
Go under main.
Under main, right?
Copy
and paste and put under main, right? So now we have below main. All right? And we get to now define what these three functions do. Two of them, they're already kind of defined how you're supposed to write them, right? We just have to learn the pattern. And then one of them, we kind of get to make up what happens. All right, so let's look at our accessor and mutator. Right, our accessor returns a Boolean, so we start with bool. Right, it's part of the pi class, so it's pi colon cooked. Right, was there anything in the parentheses before?
Nope.
So is there anything in the parentheses down?
Nope.
Nope, right, and then change by semicolon parentheses. Right. Accessors access the value. How do we get data out of functions? What word do we use? Okay, so we return, what are we returning?
Cooked underscore.
The Boolean, right? Cooked underscore, good.
Nice.
So we just return cooked underscore, semicolon, closing curly. That's an accessor. Accessors always look the same, right? They're named after the attribute and they return the attribute, right? There's nothing really special about them, right? So that should be pretty easy for us to get used to that pattern of what they look like. Mutators, they're not that much more complicated, right? But mutators are a place where you want to have, right, error checking if you need error checking. We don't really, right? So void, pi, colon, right, set, cooked, right, and then bool, cooked. Right?
It's not underscored.
Not underscored. The parameter is not underscored because that's the data coming in, right? Data comes in via my parameters. right? But the goal was to set the attribute, right? Because the goal is to set the cooked status. Does that make sense a little bit? Right? So in all your mutators, at some point, you need a line of code that says, right, cooked underscore becomes cooked.
Which is right there in the set, right?
Which is what you're going to write in here. Right? So here, my attribute is called cooked underscore. I'm going to agree that's my attribute. I'm going to give it the value that was supplied to me.
It gets assigned the cooked value. This is starting to make a little
And
more sense.
mutators will always have a line of code like
This is making a
that.
lot more sense.
Right? If this was crust type, this would be crust type underscore equals crust type. Right? If it was filling type underscore equals filling type. If it was size underscore equals size. Does that make sense? You will always have that in your mutator. But if it was crust type or filling type, we'd have to have an if statement, right? Because maybe we won't have a limited types of crust and limited types of fillings. So we wouldn't want the user to give us all possible characters, but only certain characters, right? So that's where our error handling would go here. Booleans, there's not a lot of error checking because there's only two possible values for Boolean, and we're good with both values. So I don't need any error checking, right? Either the pie is cooked or it's what?
Not.
Does that make sense a little bit? All right, let's write the third function. Right, let's cook it. Void pie, colon, right? What do we call it? Cook pie? Looks a little redundant. That's okay. So the cook pie behavior's job is to do what? Cook my pie, right? And so really, in this, right, we can maybe see out, right, cooking pie. Right, maybe with a new line or something like that. And then we just set cooked underscore to what?
True.
The true, right? Because my pie is cooked. Does that make sense? Right? So if it was false, not cooked, I could call the cooked pie behavior, and then it would change the value from false to true. And if it was true, we just what? Override it and leave it true, right? You got a misstatement there like, right? If cooked equals true, see out, you burnt the pie. I mean, you can mess with that.
Or you could say, you'll wait. Your wait is 5 minutes, or
Right,
yeah, okay.
Right, you can do whatever you want, right? That's the beauty of it.
Just booleans are so cool for stuff in our
For
code
statuses, yeah.
that I wanted to see how we throw that. Thank you for that.
Now, I've done a lot of work. I haven't really done anything yet.
Nope.
No, not until what?
You write in main.
I write main, right? So let's write main.
A lot of stuff.
In main, right? Let's make a pie, right? To make a pie, I use my type, and then I give it a name, right? My object name, right? So the type is pie, right?
Pie.
And then what? And someone give me the name of my pie.
Apple.
Ew.
Apple. We have an apple pie.
Chocolate pie.
Ew.
Chocolate.
It's apple pie.
I have two pies now, right? Remember, apple and chocolate are both distinct objects, but they share the same blueprint, which means they have the same attributes and they have the same behaviors. Right? The values of their attributes right now are what?
Garbage.
Garbage, right? Today we're going to learn how on creation of objects, we will make sure they don't have garbage. That's what I'm going to teach you today. Right? Yeah, garbage pie, that sounds terrible. Right now your apple, right? But really, you get an apple pie, right? Whose type is pie, right? It has 4 attributes, right? What are my 4 types? Crust,
Filling, size,
filling.
and cooked.
We're gonna make them shorter. Filling, size, right, and cooked. Very good with that?
Yeah.
And if I made a chocolate pie, it would have all the same 4 values as well, right? Each pie has the same attributes, has access to the same behavior, right? Remember, when you write your blueprint, you do not know the names of your pies, right? You never in your blueprint say apple pie, or you say chocolate pie, or you don't say apple dot or chocolate dot, because the blueprint has to work for any pie, including garbage pie.
Okay, so in the void pie, cooked pie, the one on the right, is that where, like, say chocolate pies are served cold, is that where you would put the condition that it's okay, that you want the condition to be false, that it's not cooked?
Possibly.
Is that where you would write that though?
Yeah, right, you say if pie type equals chocolate,
Right,
then, sorry, we don't cook those types.
because you could write something where it's set for all types of pies, but if you have one that's supposed to be the opposite, that would be the place you would write that.
That'd be in the cooking process.
Okay, thanks.
Actually, we don't cook that. I don't know what cooked chocolate. Well, they do.
Well, chocolate pudding pie, but
That's not right.
I just wanted to see where you would write that.
Right, because if you think about it, all member functions, right, these are member functions, all member functions have access to all member attributes. I don't call member names. So that's where you can check the value of those. Right, that's where you do. So we have 2 pies, right? And then we can say apple, right, dot set, right, cooked, right, and let's just say false. Right, and that says, go to the set cook function, right, pass in the value false, and use the object called what?
Apple.
Apple. So we'll go to the set cook function, right, the value we brought over was what? False. So the parameter becomes the value, right, so cooked here without the underscore is what? False. And we say cooked without the underscore false gets assigned to what?
Cooked underscore.
Cooked underscore. Who's cooked underscore?
Apples.
Apples, because we called the function on apple. Right, and so cooked underscore becomes function ends, and I go back to the call, right? The function ends, there's nothing else going on. We go back to the call, right, and we're ready for the next line of code. Right? Next line of code, we could say, right, apple dot cooked pie, open close paren, right? That says go to the cooked pie function and use whose values?
Apples.
Apple's values. Go all the way to the cooked pie function, right? We get a message, cooking pie, right? And then cooked underscore becomes
True.
true. And cooked underscore whose? Apples cooked underscore, right? Because I called cooked pie on apple. So this cooked underscore becomes what?
True.
True.
Interesting.
And then we do things like this. We can say if, right, apple dot cooked equals true. See out, right, enjoy. Else. See out. Alright. Yeah.
Yuck.
Unless you're into uncooked apple pies.
Gross.
Alright. Let's talk about this.
April didn't do this last semester.
Right? Cooked, and remember the name of that? We called it a what? Accessor, right? So this is what happens. This says, go to the cooked function and use whose values?
Apples.
Apple's values. So we go to the cooked function, we are using Apple's values. And what do I return what?
You return the value of cooked underscore.
Right? So we return Apple's cooked underscore's value. Right? Apple's cooked underscore value is what?
True.
True. So this thing that I highlighted or boxed in is what? True. A function that call, right, when you call a function that returns a value, the function call becomes the value. Right? So really, apple.cooked at this moment in time is what? True. And does true equal true? Yes. So what do we output? Enjoy. Right? If I hadn't have cooked a pie, right, then this would have returned what? False. Does false equal true? No, we output what?
Yeah.
That make sense? A little bit? We're kind of see how the pieces are slowly, I know there's lots of pieces.
That thing saying
Slowly
that
starting
becomes
to
the
come
value that helped. That was like an aha.
To get the value back. Yeah.
That's all only for that one attribute, which is the boolean cook, right?
Right. Because accessors only access their thing, right? But theoretically, there's probably also an apple.crust type, and an apple.filling type, and an apple.size, right? There should be an accessor for each one and possibly a mutator. Good? Right? I say that, but sometimes you don't write accessories and mutators if, right, maybe you don't want the user getting or setting these values. Right? Sometimes that happens. Right? You're going to use them in your class, but you don't actually want the user to have access to them. So you only write accessors for the things you want them to get the values of, and only write mutators for the things you want them to change the values of. Okay.
For your public and private classes, are those all in the same curly brace?
Yes.
Okay.
So class pi, open curly brace, and at the very bottom, close curly brace, semicolon. Right? This is the only time, I'm going to highlight it. Right? The only time that you really have a semicolon on a curly brace is in the class declaration. Right? Notice these curly braces, do they have semicolons?
No.
No. Does my if statement have semicolon at the end? No, right? Only in the class declaration. Only in the class declaration.
So maybe this is a silly question, but if you're going to use accessories, why not just
Okay, you're asking if we're going to run accessories, why not make these public? Well, because what accessories do, they only what? Get the value. But if you make these public, not only can you get the value, you can also what?
Change them.
Change the value, right? And like for crust type and filling type, I might not have a Z crust type. Right? So I don't want the user to give it a value that doesn't make sense for my type. So because we make them private, then we have to write our accessories. Right. Because in these mutators, you would have interchange. Right? So you would have a void pi set, right? Set crust type, pair crust type, right? But you wouldn't just say crust type equals crust type underscore. You would say if crust type doesn't equal, right? I don't know what kind of crust types there are, right? Then you would handle it, right? And so you're forcing the user to go through the behavior. They don't have direct access, right? So you basically, you're in your mutators, you're limiting the possible values, right? If I only want the value to ever be 1 through 10, then in my mutator, I want to make sure that the value given is 1 through 10. If there's anything else, I need to either, right, cancel the whole program and say you don't know what you're doing, or handle it nicely, or whatever.
Wouldn't that be kind of like what CU Reader does?
Yeah, CN Reader does that a little bit, right? So the user inputs something, right, and it checks it to make sure it's the correct thing. So it's kind of along those same lines. CN Reader, though, only works with user input, right? And functions work with parameter input, which really could come from anywhere. Could come from the user, could come from you hard coding it, could come from a formula, could come from one.
And since you're having, so voids are things that do something,
Right.
you don't want those willy-nilly values to go around. You want to set it so that the do something functions work properly.
Well,
And that's why you're error checking.
If you notice this, right, what I highlighted because it returned a value, I said it was true, right? Apple.setCooked doesn't return a value, right? So I can't say apple.setCooked plus 5 or something like that, right? Because it doesn't return a value. I can't do anything with it, right? Void functions are just go do this thing.
Right.
Right? This says, go to this function and give me a value back, right? Because I gave it a return. Anyone hungry for pie now? Yeah. Right?
Super.
These new classes are killer, man. You're like, do you eat beforehand? This is a little early, or do you eat after? But then you can't hear the lecture over your stomach. It's like, right? Yeah.
Try to hold out for in and out.
You try. Yeah, but I get off at like 5:30, so I can't hold out that long. Anyways. Questions? I might erase that, but I'm not going to erase this.
Are we?
I'll try not to erase that. Maybe I'll write it on a different whiteboard.
Do you have any recommendations for practice like the issue you just discussed? Is there a chart somewhere?
I don't. Just my examples. I'll do this again next class. After spring break. You really will be confused because you're like, yeah, that was a long time ago.
Will we be able to do functions that have like loops and stuff in them so that action's happening, those iterations are happening?
Right.
Like, will we hit that at all in this class?
We will kind of, right? We're asking the questions, right, about loops and our function, that kind of stuff. We'll hit that, but really, you have to think about each of these functions. One, they're each their own distinct function. Two, whatever you can do in main, you can do in these functions.
Okay.
right? So if you want an if statement, which we wrote, no, we never wrote an if statement. If I wanted an if statement in here, I could write an if statement. If I wanted a loop in here, I could put a loop.
So if each of those things were entities of like our guessing game and our shooting game, those, the void pie cooked on the right, that's where you would put the game itself?
Right.
Okay.
And probably like, you probably would have written a function, you know, your if statement that had the 9 choices. That probably would have been wrapped up in a function. So you just would have passed in the user's choice, and it would have told you the output.
Would have gave them.
Right, so you're breaking up into these small pieces, and then kind of in main, you kind of put the pieces together. Which is what you'll do in code assignment 5 when you make
So
your
like
own.
that's where you would do like void set, guessing game, parameter,
Sure.
boom. Okay.
I think you have to decide what are the attributes of my game and all that stuff. Kevin?
Where's your return 0?
It's not there,
Oh.
because it'll actually work, but it should be there. Syntactically, it should be there. It's right there, don't you see it? Other questions?
Non-member function?
A non-member function is a function that's not part of the class, which we have not talked about.
That's like my random for loop thing that you tell me to break.
Yeah, a little bit. Right, but that was all still, I think, in main, right?
You put it above.
Oh, yeah. So, non-member functions are just functions that aren't part of the class, but right now, those don't exist for that.
And you said bad practice too, right?
Well, no, we'll get to where we will use them. I'll introduce them. But right now, so far, because we're trying to do everything object-oriented, not imperative, right? We're really trying to write everything in class objects. But we will learn how to write our own functions that aren't part of the class. We'll do that. Anyway, a couple weeks. Everything's a couple weeks down because next week we get off.
I'm so thrown off because I'm in a fast track class. So
Okay.
like I'm like,
You're almost done. You probably are done.
oh, we have like a week after spring break. Yeah.
That's not that it comes out that way. Well, let's finish before.
Honestly, we haven't had homework all week because he's like, I don't care. Let's just not do homework. So it's been nice.
This is lecture 11.
12, I think.
12. This is lecture 12.
I copied down the entire board, but it's not compiling.
Did you put this above main? This in main? That over there?
Yes, but it says pi was not declared in the scope.
So that means you did something wrong with this. Right? That's fine.
Oh, I didn't capitalize my P.
Case is important. We get that into functions via what? How does that come into functions?
Oh, through the private.
So mutators are one of the functions, right? But what are the things that we use?
Parameters?
Parameters,
Yeah.
right?
Yep.
So the things, the variables inside of our function declarations are parameters, right? They get passed in via arguments. So false, that's an argument. The value being passed into my function is an argument. The variable that holds the value being passed in that I use in my function is called a parameter.
That's where you put cooked non-underscore inside.
Yes. To get that out of functions, we use what? Return, right? And we have to give our function a return type. First word of the function is return type, right? In main, I'm basically saying that main returns a what? An integer. That's how data comes out, right? Obviously, we're returning 0, but we're not getting that value, right? Actually, the operating system is getting that value. And it can choose to do it what it wants. Which we know when we run our program code, it says at the bottom, right? Return, what does it say? Status 0 or something? Exited status 0, whatever. That's where it comes from. Minimum variables, when it comes to encapsulation, should they be public or private? Private, right? We don't want members, right, messing with our, or not members, users messing with our variables, right, our attributes. The function we use to get member variables data, right? The functions we use to give our attributes data are called mutators. And the functions we use to give the data out are called accessors, right? Mutators change data, they get data in, right? Accessors get data out.
Mutators are the set.
Mutators are set.
You're
Set
setting.
underscore attribute name.
You're setting the value.
We call them gators and setters. You'll hear that a lot.
Sick.
Hey, remember that class we made last class? Right? Does that kind of look like it? Right? This is just a plain old member function, right? Int month and int day are what? Where's special
Integers.
names from? What are they? Yeah.
Accessors.
Attributes?
Accessors. And set month and set day are?
Mutators.
Mutators, right? You know they're accessors because they look exactly like the attributes. Right? You also know that all member functions have capitals, whereas our accessors and mutators have what?
Lowercase.
Lowercase. Because if you think about it, you're going to start using accessors and mutators like you use variables, right? Because they act on an attribute, which is a variable, right? And so we lowercase them to try to remind us that they're like variables, right? They're messing with variables. Whereas output could mess with variables and could do other stuff too. That makes sense, right? In the private section, I have 2 member names, right? These are the attributes of my class, right? And they will be the attributes of my objects when they get created. Good there? All right. So let's talk about constructors. That's what we're going to talk about, and default arguments.
And that's where you'll have those be not value garbage.
Yes, right? Because when I create an object, the attributes values are garbage until, right, I use either mutators or some other member function to change the data, right? But when I create regular variables, integers, doubles, right, they start with garbage, but I also have the choice to do what?
Assign them values.
Assign a value, right? That idea is called initialization, right? So I can initialize variables on creation, okay? Objects have that same ability, right? And we do that via a member function. That member function is called a constructor. Okay. So let me catch my slides up with whatever the heck I'm talking about.
I'm a question asker, sorry.
No, you're good, right? So constructors, right, they're called constructors because they construct the object. Does that make sense? Constructors construct the object. So their goal is to set values of the attributes. And later on, we'll learn that there's other things that we might have to set up. So their goal is to set up your object, okay? And assignment 5, which is way down the line, you're going to create a game. In the constructor, you're going to construct kind of the defaults of the game. Think about assignment 2, right? Some of the defaults of the game would have been, right, players guns unloaded as, right, or players gun loaded as false, and users gun loaded as false, right? That kind of stuff. Set up some of the initial values. So you don't always have to set up all your attributes, but you're going to set up the ones that need to be set up. Okay? So that's what constructors allow us to do. Okay? They are functions, so we define them the same way that we define all of our other functions, but with a couple caveats. And so we'll look at them. Constructors are named after the class. So if my class is pi, then the constructor's name is pi. If it's day of year, then my constructor's name is day of year. Okay, that's not a choice that you can make. To make a constructor, it's always named after the name of the class. And constructors don't have a return value, they don't have a return type. Sounds like void, but you don't even say void, you just say pi, right? Pi is my constructor, or day of year is my constructor. There is no return, int, void, double, char, whatever. Right? So if you think about it, a constructor is a function that will run one time and only one time. All my other functions I can call as many times as I want. Constructors run one time when the object is created, right? At creation time. So they run one time really per object, right? One time per object on creation time. So here is my day of year constructor. You'll notice most of the time constructors take input, which means they have parameters. Right, in this case, day of year had 2 attributes, month underscore, day underscore. So how many parameters do I have? 2. 2, which means on creation of my object, I can actually give it a month and I can give it a day, which means never will my object have garbage values. These are parameters. When I create my object and pass in the values, those are arguments.
And it's in order that you put the parameters.
It's in order that I put the parameters. I don't know what my notes are. Main status class, we said that. No return type, right? Notice there's no int, void, double, anything like this, right? It just is. Right? There actually was one of those in our last lab when we made our, what did we make, counter type? Does that sound right? There was a counter type at the top that I said don't touch, right? It was a constructor, so that when you created your counter type object, it actually set it up.
That was like your fail safe so that we could do the other parts?
Yes. Right? It should make sense. Constructor should be public because who's creating the object? The user, right? And so if you don't make it public, then the user can't create the object, which means that your object is worthless. Here's the definition, right, below main. So you're going to go through the same process. Copy the constructor, because it's a function, paste it below main. Class name, colon before function name, semicolon curlies, right? There's two weird things. One, no return type. Two, the name of the class is also the name of the constructor. So it just looks redundant, right? Day of year, colon, day of year, right? This is my class name, right? This is my scope resolution operator, and this is my function name.
This kind of reminds me of how you would write it in JavaScript.
A little bit.
You would just write function in front of it.
And now in JavaScript, you can actually say underscore constructor. Yeah, we said that. Yeah, we said that. Okay. So how do I use it, right? That's great, I have it, but now I said that constructors run when you create the object, which means if this constructor, I'm going to say the constructor takes a month and a day, that means when I create my object, I have to provide a what? A month and a day. So let's look at how we do that. Just like that. Create 2 dates, right? Both of my day of year. Date 1 is my first object, and everyone see that I have parentheses, which I never had before, and I pass in the values, right? 7, right, being the first argument, and 4 being the second argument. 7 gets passed into the first parameter, right? 7 gets passed into the first parameter, and 4 gets passed into the what?
Second
parameter. And notice what happens. That 7 gets stored into month underscore, and that 4 gets stored into what? Day underscore, right? So I've now created a day of year whose month underscore its attribute is 7, July, and whose day underscore attribute is what? 4, right? So now my date 1 is the 4th of July.
So that would be in place of like where you put apple and chocolate.
Right. Right. Here you would have to say apple, paren, and then pass in the values. Right? Date 2, I'm passing in 5 for month, 5 for day, right? So date 2 becomes Cinco de Mayo. So I get 2 date objects, right? Which I think is my question, right? How many objects created? 2, right? The created objects have also been what?
Initialized,
right? The values have been provided, so they've been initialized. So my objects don't have garbage values, right? Day 1 and date 2 are not garbage dates, they are real dates. And all dates have to have values now, because I said when you create an object, you have to provide me what? 2 integers, right? A month and a day. So you cannot create a date that does not have a month and a day. So all objects that are created that are day of year are going to be initialized. They're like setting up the instance. So when the constructor's done running, you have your instance. You have your object. Right? You could think of a constructor kind of the equivalent to the same thing. There's my 2 dates, and then I call date 1 dot run the function, pass in the values. Date 2 dot run the function, pass in the values. This doesn't work, but if you want to frame it in what we've already learned, which is probably still easy, right? That's how you would do it, right? You cannot do this. You cannot take an object dot constructor. That doesn't work, right? The constructor gets called when you create your object, right? So look at the top one.
So is this how like a company could put like a age gate on like a violent video game preview? They could have like a file that keeps track of the date, and as you're 18, it changes.
Good, yeah.
And is that how they would write that?
Yeah, I mean, dates are going to be objects in any programming language that you deal with. So yeah, they can check what is the current date stand. Because constructors run only when the object's created. So it's been defined as when I create an object, if I pass values in, those have to go to the constructor. The only time a constructor runs is when it's created.
Can those parameters be variables?
Sure. Well, arguments.
Right, so that way like...
Right, so you're saying 7, 4. They could be user input, stored in variables. They can be expressions, right? It could be 1,000 divided by 100. We could give you 10, right? Right, they could be anything. Because what happens is the argument's value is calculated, and the value is what's passed in. So when you have a variable, the variable's value is calculated, and that's what's passed in. Right, so you get a copy of the data. You could. Yeah, you could put the equation inside of the parameter. Very rare if you do that, but not yet, but I'll do it for now. It has to be an expression, right? So expressions are things that become a literal value, which means it can be an expression, a variable, or a literal, right? And expressions allow for other function calls, right? So you can actually, it's kind of weird, but instead of that 7, you can actually say reader.readInt 1,12.
Sick.
Right? Which means that before it runs the constructor, it actually goes out to the user, gets an integer between 1 and 12, that comes back, right? Because the function returns that value. So you type in a 1, it gives you a 1, and then the 1 gets passed another.
So then it goes to that file, checks the readInt part, and makes sure
comes back, brings value back.
That's kind of rad.
It's super cool, but I don't really want to do it because that's like lots of levels going on there. But yes, it could be.
You'll get us into
expressions
that,
can
right?
have function calls in, right? Because I could say apple.cook times 2, right?
Bless you.
Any expression could be 7, any expression could be 4. So long as it becomes a value, that's what you do. All right, let's look at it. No. Yes. So I still have our example up from last class, right? With our output function, our input function, our mutators, our accessors, right? Remember, output function just outputs the date. Input function sets them via the mutators, right? The accessors just return what they're accessing, right? And the mutators change the data, but remember, what do we put in the mutators? Error checking, right? We did a little bit of error handling in our mutators, right? We didn't want to always store them up, right? So this is straight out of what we did on Tuesday.
Lecture 12.
Make sense? Right, so what I want to add now is a constructor, right? The name of the constructor is what?
Oh, no, I'm on his Cloud9.
Come on, help me out. The name of the constructor is what?
Davier.
Right, Davier, because it's the name of the class, right? Right? Is it a return type? Is it void Davier?
No.
No, it's definitely not void. Right? No return type. And then usually, almost always, your constructor will have parameters, right? Because the goal of the constructor is to initialize value. Right, so we're going to do 2, int month, int day. Once I have that run, right, I'm going to copy it and paste it where? After main. Paste it, change the semicolon to curlies, and put class name, colon before function. Now, if the goal of my constructor is to initialize my object, right, what am I going to do with the month and day parameters? What am I going to do with them?
You need to give them values.
Store them, right? They have values. They will have values, right? The blueprint. And store them where?
An underscore.
Right? So month underscore equals what? Right? And what? Day underscore equals day. Does this work?
Mm-hmm.
Yes. What's the problem? There's a problem.
It can answer a large number.
What?
I think it, yeah.
Integer can be a large number, right?
12.
Because remember, month is supposed to be what? 1 through 12, and day is supposed to be 1 through 31. And right now, these could be any values. Agreed? All right, remember we wrote that functionality last class in our mutators, right? Let me scroll down again real quick. All right, that's a long ways to scroll. But you know, in our set month function, when we take a month, right? Everyone see we have our if statement to check to make sure it's a correct month, right? So in here, what I want to do is I don't want to say month underscore equals month. What do I want to say? Set underscore month. Call the mutator, right? And give it the month. And then right instead of day equals day underscore or day underscore equals day, we say what? Set day. Now that only works because I wrote the mutators, right? You can't just say like set day and it's going to work, right? You have to have a function called that in order for that to work. But remember, month and day without the underscores are the user supplied values, right? Month and day without the underscores are the user provided, right? They're the parameters. And so whatever the month is that was given to me, I'm going to send it off to that function, let it do the error checking, right, and handle it. Because how many places would it be good for me to have error checking? One place and have everything else use that error checking, right? Put the error checking in one place and have everything else use the error checking. Does that make sense? All right. You'll notice, right, I'm going to take this, I'm going to show you something that we did last class. Like a little bit farther. There we go. My constructor looks a hell of a lot like what?
Your function.
The input function. Everyone agree?
Yeah.
Right? In fact, they look exactly the same. But it's all about timing. The constructor runs when?
Before.
When the object's created, and how many times does it run?
Once and only once.
How many times can I run the input function?
As many times as
As many times as I want. So I have to write two functions that basically do the same thing, because one's my special constructor, it runs once, and one is the input function I can run as many. You could have, right, in my constructor, I could have just called input. Right? I could have called input and passed in month and day, and then input would have called what? Set month and set day. But maybe since it's so short, just let it call set month and day. Does that make sense a little bit? Right? One runs once, run once as many times as possible. I'm going to try to run my code, right? And we're going to see a compiler error, and we'll talk about why. Hopefully it's the right one. All right. It says in my file, line 27, no matching function for call to day of year, colon, day of year, open, close, paren. All right. Day of year, colon, day of year tells me it's a constructor, right? Because the function name is the same name as the what? Class. And it's saying there is no matching function call for day of year, open, close, paren. So there is no matching function call when you don't pass in any values, right? Well, when did I call it? It tells you when, right? Sorry, on right below it says day of year space today. Right? That looks like object creation, yes?
Yeah.
When an object is created, the constructor always gets called. And it's saying you don't have a constructor that takes nothing.
Oh,
It's called the default constructor, right? So the only constructor I have takes what? 2 integers. So when I create my object, I have to pass in what?
2 values.
2 values, 2 integers. Right? And it says, right? The next error message says no candidates are. It says I found this one, but that one takes what? 2 integers, right?
Yeah.
So I didn't find one that took none, but I did find one that took 2. Maybe that's the one that you were trying to call. Right? So how do I call it? I put parentheses on my object creation. So now I can say today, right? And then I can do open paren, close paren. I can pass in 3, 15. And I can make yesterday, open, close paren, and pass in what?
314.
3, 14. Do I need to say today.input anymore?
No.
No, right? I don't even need to use my mutators.
Int main becomes real small.
Yeah, right?
That's cool.
It makes just like run these commands, right? All the logic's wrapped up in my function. Right? So today gets set to 315 because we defined the constructor to do that, right? Yesterday gets set to 314 because we defined the constructor to do that. So when I say today.output, what do I get? March 15, right? And when I yesterday.output, I get March 14. So if I run this, hopefully that'll work.
Hey.
Hey, it all worked. Questions on that? Constructors are a special function that runs once when your object is created. It's the way that you initialize objects and give them values. Sound good? All right, let's move on to the next thing. All right. Let's talk about overloaded constructors. So we have to talk about what overloading is, and then we'll talk about how we get overloaded constructors. Right? C++ allows you to write multiple functions with the same name. So I can actually write 4 functions called output all in the same class. But the only way I can do that if it differs in the number of parameters or actually the types of the parameters. So an int function versus a char function versus a double function. Okay? We'll get into that more later. Where that comes useful for us right now is that we can have multiple constructors. Because all constructors have the same name, right? The name of the
Object or
class,
the class.
right? The name of the class. Good. Right? And so sometimes we want to initialize our objects different ways. Right now, we wrote the constructor that we have to initialize it with 2 integers. But what if I only wanted to give it a month? Or what if I didn't want to give it anything and just I wanted to set up kind of the default setup? right? We can do this by overloading our constructors. Right? So let's talk about that. I think I said this, right? A constructor with no parameters is called a default constructor. Okay? That default constructor actually got created for us automatically last class. Because last class, did we create a constructor? No, and if no constructor is created, C++ will automatically create you a default one. Doesn't do anything though, because it left our values as what? Garbage, right? But we can actually, now that we started defining constructors, define one that has no parameters. So what should the initial values be if the user does not want to provide them? We got to make that decision, right? What that's supposed to look like. Right? So, right, when I create objects and I don't have any params on it, right, that calls the default constructor. And we just saw my example, did it work?
No.
No, because I defined one that took 2, and I did not actually define another one that took what? 1 or 0. Right? So when you define a constructor, you need to define all the constructors that you want to have.
So that would have worked if you did another accessor with it?
Right? Not
Or
another accessor, another constructor.
Constructor.
Right, which is what we're going to do. All right. So if I have this constructor, right, day of year and month and day, that's the one we just created, right? I can do that day of year today, 429, right? That works. But I can't do this, right? That's where we just saw that error message, right? Unless I created that. This is another constructor that has how many parameters?
0.
0, right? And this, when I create this object, how many arguments am I giving? 0, right? 0 matches 0, so it's all good, right? And this object creation, I'm giving how many arguments?
2.
2, and they're both of type what? Int. And this day of year constructor has 2 parameters, both of type int. So the type should match as well. All right. So let's add those overloaded constructors and kind of see what that does. So there's one constructor. I'm also going to write a default one. Day of year, open, close paren. Everyone see it's the same name?
Yeah.
But it differs in the number of parameters which is allowed in C++. So there it is. The order does not matter, just as long as they're all there. Right? So I'm going to paste it down here. Right? Change the semicolon to curlies. Right? Do day of year, colon, colon. Right? So this is my default constructor. Basically, the question is, if no values were given, right, I have no parameters, so no values were given, what should my object look like on initialization? Right? And I think last time we said, like, when the user gives us an error, we'll just make it a 1. Right? So we could just say, right, month underscore equals what? 1. And day underscore equals what? Equals 1. If I don't do this, then month underscore and day underscore values are garbage, right? But here, if I create an initial object with no values, it will still set it to something that has been defined, in this case, 1. So when I go back up, right, instead of saying yesterday 314, I can now actually just say yesterday. Right? No parens. Yeah, it's a weird quirk in C++. No parens. But it will call the default constructor that has parens. So this will set up today with a month of 3 and a day of 15. Everyone agree? Right? This will set up yesterday with a month of what? 1 and a day of 1, because that's what we defined it to be. So when I run it, right, I get March 15th and I get January 1. Does that make sense? Right? I can't though, right? I can't make one that like only takes a month, right? So if I try to pass in a 3 here, or I try to compile it, right, I'm going to get that same error message.
Unless you went up to public and wrote one.
And then wrote another one, right? It's kind of fun, right? It says these are the candidates, and how many candidates do I have now? 2. Right? So here's my first candidate, day of year int int. Here's my second candidate, right? Day of year nothing. So it's like you gave me 1 int, but I only have one that takes 2 ints or one that takes what?
No int.
Right? So fix it and make it work. Does that make sense? Any questions on that? Where? Cons expression can express their arguments. Up here. This one here. It says no candidate expect 0 arguments, 1 provided. It says no cons expression, day of year, cons, day of year. That gets created automatically. That's all.
But that's because you tried to run just a month, right?
Which I don't really want to talk about, but it gets also created automatically. So if you want to create a day of year from another day of year, that is possible. Yes. Cons expression just says an expression. It's an expression. I just want to fix it so it's compiling before we do our last one. All right. One last idea that's not really related. All right, but we'll get through it really quick. So that's the idea of default arguments. Remember, arguments are the things that are passed into parameters. Right? So arguments exist in these things called function calls. Right? So function calls, right, are things like apple.setCodes. Right? When I use a function on an object, that is a function call. So the things that you put in parentheses are called arguments. Right? So here when I said set underscore cook paren false, false was a what?
Argument.
Argument. Arguments get passed into parameters, right? And so default arguments are saying, if no argument was provided, what do you want me to do? The default is, I can't make this work, right? I said I take an integer, you didn't give me an integer, sorry, no compile.
Like else or
Right.
or the
But
default.
now we're gonna be like, you didn't give me an integer, I take an integer, but there's a value that I can use if you don't give me an integer. And those are default arguments. So here I have a function called setVolume. SetVolume takes a what? A length, a width, and a height. Okay. Notice width and height have what? Equals 1 next to it. That's a default argument. Basically saying that if a width is not provided, I will use what value?
1.
1. And if a height is not provided, I'll use a 1. Does that make sense a little bit? Okay. We're going to do more. Another weird quirk of C++ has 2 quirks today. One in the no paren. The second one is default arguments you only write in the class declaration, but not in the class definition. Or sorry, the function definition. So I've been harping on this like the past 2 weeks, copy, paste, where I say it never changes. Well, with default arguments, it does change. You have to get rid of the equal value in the below name spot. And I'll show that to you.
Which makes sense because you don't want any content inside your function. You want to do your own content.
You can have more than one default argument. I showed you 2, right? Both width and height or whatever were default is 1. But if you're going to only have 1, it has to be in the rightmost position. Okay? So you can't put default arguments wherever you want. They always have to start in the rightmost. Otherwise, C++ won't know when you leave something out, which one goes to where. Right, so you leave off arguments, you go from left to right. So here's setVolume, right? So I couldn't say int width equals 1 and then just say int height, right? The default argument always has to be in the rightmost position. I have more than 1, but it always has to start in the rightmost. And length has no default, right? So I can do this, object.setVolume 10, 5, and 2, right? That's a function call. 10, 5, and 2 are my arguments, right? 10 is going to go into what?
Length.
Right, 5 goes into, and 2 goes into height. Notice they override the defaults, right, because I provided a value. Right, 10 and 5 says 10 goes into what? Length, and 5 goes into width, which means height is 1. Right? SetVolume 10, length is, width is, height is 1. If I just said object.setVolume, open close paren, it would say no matching function, right, for setVolume, open close paren. Right? It would say candidates are this, that takes 1, 2, or 3 integers, but not one that takes 2.
That's right. That saves you like a whole if statement in a function somewhere.
to kind of bring those two ideas together, one of default arguments and one of overloaded constructors, I want to give us a quick example. I think I'll do it on the back, because I don't want to erase this. And it's good for you to move backwards so you wake up. Quick, close the game that you're playing on your computer. Harry, you had a question?
Yeah, is there any good reason not to set anything to default arguments?
Yeah, I mean, there can be, because sometimes you want those two values provided from the user. But if you're like, this, right, so default arguments are like optional, right? I could take this value, but I don't need it, because I can provide my own value. That's where default arguments come in. So when the parameter is optional, then give it a default argument. If it's required, don't give it a default. So, right, let's just assume I have CN reader set up. So I say CN reader. Everyone good? Except for the fact that I don't know how to make a semicolon. Right? Now I said you could say, right, nx equals reader dot reading, right, open close paren. Everyone good with that? But I also said you can say int y equals reader dot reading, and what else can I give it?
Parameters.
Parameters at 1, 10, right? And that's being handled of one of two ways. Okay? Either it's overloaded, so same function name, one function that has no parameters and one function that has what? 2 parameters. That's one way it could be handled. The other way it possibly could be handled is that 1 and 10, right, could be default arguments, right? It could have default arguments. So if you don't provide a value, it, right, basically allows for any value. Right? Those are the two ways that it could work. But I wanted to show you an example of where you've actually already used it, right? Because you called the function 2 different ways. You just didn't realize it was a function callback, right? So this is looking for a readint function that takes nothing, right? No parameters. And this is looking for a readint function that has what? 2 parameters. Has anyone ever tried to do it with 1? It doesn't work, which clues you in that they're not default arguments. Because default arguments would mean that you could leave off the 10, right, and just do like a lower limit. But no, you either have to do it this way or this way. So it's not a default argument. There's actually 2 read integer functions that basically do the same thing. One takes no ints and one takes what? Let's just make us some default arguments for our program so we can kind of see, all right, what they do, and then we'll get into today's lab.
Sorry, did I run out of your foot? No.
So I'm going to default input, right? I'm going to say the day is going to default to 1, and the month is going to be defaulted to 1. Basically saying that for the input function, month and day are optional. You don't have to give it. If you don't give any values, I have values that I can use.
Would you then want to switch that into the private side so that they can't change your defaults?
No, they can't touch my defaults.
Okay. I just was curious because
No, because if I move the function in private, then the user can't use it.
Got it. Okay, thank you.
So once I do that, right, I scroll down to input. Do the default arguments go below main? No. So do I need to do anything to this function? I actually don't. I don't need to do anything to the function, right? Month and day will either be the values the user gave me, or they will default to what? 1. And no matter what, I want to take that 1 or whatever value and set it, right? I want to take that 1 or whatever value and set it. So I actually don't have to change anything here. What does it allow me to do now? Call the function in different ways, right? And so now I can say, so I can put the dates, then I can say like, today.input, right? I could say yesterday.input, right? And then just pass in like a 3. And then when I duplicate these, this says call the input function and give it how many values?
None.
None. So it will have to fall back on the default argument, right? 1 and 1. This says call the input function on yesterday and give it the value of 3. So month will be 3 and day will be 1. So that's the default. So when I run it, right, all of a sudden I get, right, January 1, because I didn't give it any values, and what? March 1, because I gave it a right? It actually makes some of your functions more nimble. You don't have to write the function once, but say, I can take varying amounts of input, right? Because these are options. I don't need them, but if you give them to me, then I'll use that value as opposed to the value that I want. That makes sense? All right, you ready for today's lab?
Sure.
All right. You know, there will come a time where I won't lecture for like hours and hours, but that time is not great.
It's not yet.
I won't put my money on it.
Yeah, that's probably a good idea.
I don't have any money.
We had some short lectures, and now we got too much. That's good. All right. So today there is no answer sheet. It just is fraction, not CPP. Okay, so you are just writing a class, and that class is called fraction, not CPP. So we kind of set the class up for you, right? And then it'll be up to you and maybe a partner to work on it together, right? And get the answer. That sound good? Right? Remember, today's lab is harder than the coding assignment. So make sure you get the code assignment in. It's like 3 points. Okay? Make sure you have assignment 3 on Cloud 9 before you leave today. Because maybe you forgot to pull it down. I don't want you emailing me at 11:50 tonight saying, where's the file? You never gave it to me. No, I did give it to you. You just didn't listen to me. All right. What was that? Huh? I said something. So you're going to make a class called fraction, right? Please don't write it from scratch because I've written most of it for you, at least what it looks like. Right? So I'll show you where to get that as well. Right? This is what the class is going to do. It's going to hold a fraction. A fraction has 2 main attributes. A numerator, the number on top, and a what? Denominator, the number on bottom. And so you're going to be able to manipulate those attributes and do some things with it, right? Those are the behaviors of my fraction class, right? So you're going to write a constructor to set the numerator and denominator. So we'll have 2 parameters, in numerator and denominator. And inside of it, you'll just say numerator underscore equals what? Numerator. And denominator underscore equals denominator. Because do I need to do any error checking on my fractions for input?
You definitely don't want the denominator to be 0.
Numerator could be any valid integer, and denominator could be any valid integer.
Except 0.
So no error. Oh, good. It can still be 0.
Well, then it'll be undefined.
Yeah, right? It still is a fraction.
Yeah.
It's a really bad fraction. Anyways, you don't have to do any error checking. That's what I'm trying to tell you. You're going to write a mutator to set the numerator, right? So the mutator for numerator is called set numerator, right? You're also going to write a mutator for the denominator. It's called set denominator, right? Its whole goal is to take the parameter and store it into the attribute, which is the underscore variable, right? All mutators look the same. You're not writing accessors today because I don't want you to just get the numerator and denominator, right? D says you're going to write a function that returns the value of the fraction as a double. What that means is that you will return a double. So if the numerator is 1 and the denominator is 2, the double returned is 0.5. Good. If it's 1 over 3, it's 0.33, right? So on and so forth. Does that make sense? So that function will basically divide the numerator by the denominator and return. Notice return, not cout. Cout goes to the user, return goes back to the function that called it. But you will return it back to the function. E, output function that will output the fraction. So while D, right, returns the decimal, right, the output function counts the fraction. So not 0.5, but a 1, right, the numerator, the character slash, and then what? The denominator, right? So it's a cout statement that you're outputting, right, the attributes, and in between the attributes, a string or a character that is the. Does that make sense? All right, and then the last one, I'm going to skip over F for a second. The last one, G, an output function that will output the reduced fraction. Okay? So to reduce a fraction, right, what do we have to do? I'll write it on the back. Right, so imagine I have 10 over 30, right? That's my numerator is 10. Right, my denominator is 30, right? Reduced, what is it? Say it loud.
1/3.
1/3, right? 1 over 3, right? We know that because what? 10 goes in evenly to 10, and 10 goes in evenly into 30, right? That number 10 is called what? Anyone know?
Greatest common factor?
Greatest common divisor, right? GCD, right? Greatest common divisor. So if you can figure out what the GCD is, you can actually reduce any fraction. Does that make sense? Right? So if I take 10 and I divide it by 10, that's my GCD, right? Then what do I get? 1. And if I take that 30 and divide it by the same thing, that's the same GCD, I get 3. So your output reduced function, Cout's the same thing as your regular output function, except that instead of output in the numerator, it's numerator over what? The GCD. And it's denominator over the what? GCD. Well, how the hell do you figure out what the GCD is?
Magic?
Magic, right? There's this guy called Euclid. He's been dead for a little while.
Okay, great.
But he came up with an algorithm that does this. He's been dead a long time. Right? This is pseudocode. This is not C++ code, so you cannot just copy and paste this because it's not going to work, right? Do we use the word function in C++? No. So can you say function GCD? No, right? Our functions return values, so we have to type them.
I used to live off of Euclid Avenue in San Diego.
Right? Yeah. It's been around a long time. Right? This GCD function takes two values, small and large, and small and large have to be small and large, so large can't be smaller than small. So you have an if statement. If large is smaller than small, then you got to switch the values, right? That makes sense? Right? So GCD works, but you always have to make sure the first parameter is the small one and the second one's the large one. So you can write an if statement to just make sure that they're in the right order, right? You can't just say swap, you have to write the swap algorithm, which we've written before, right, in one of our labs. We need a temporary variable and kind of move the stuff around. It doesn't actually look like this. We did it before, so you're going to have to do it again today. And then you're going to write a while loop, while large does not equal 0, we're going to do all this fun stuff. And then notice at the end we return what? Small. If you write those steps and you pass in two values, the value you will get will be the what? The GCD. That makes sense? I would say that for last. Right? I'll do that one last. So let me show you what I'm giving you. Right? So let's look at that. So here's class fraction, right? I'm going to tell you in this, right? So you don't ever want to look at the PDF again. You can probably not have to do that because I tell you, here's the constructor and this is what it does. Right? Here's the mutator, this is what it does. Here's the denominator, here's what it does. Get fraction, output, output, reduce. What do I need to do with all those? Copy and paste below main, right? There's one more function hiding out. It's in the private section and it's called, guess what? GCD. Right, so there's my last one. Right? You'll notice it's private. We've never had a private function before. But basically we're saying that in my fraction class, the outside world does not need to use the GCD function, but we need to use it, right? So it's private. We can use it in our class to the outside world. Looks a lot like the pseudocode, right? It takes an int small and an int large and returns a what? An integer, which is the GCD. So I think that makes 6 functions that you will need to copy, paste below main, cross name, colon, colon, semicolon, and curly. Do that first, run it so it compiles, and then start filling them in, okay? Besides the GCD function, they're all one line of code. Constructor's 2 lines of code, okay? So please note that we are breaking up big problems into little problems, which means that in each function, you're not going to write these few lines of code because it does one thing really well, and that thing's really small. Right? So they're all pretty much one line of code, 2 to 3 lines of code, minus the GCD algorithm, right? Because that was long. Once again, the GCD function does one thing. What does it do? Calculates the GCD. It does one thing and it does it well. That makes sense? All right, so that's what you're going to do today. If you write it correctly, right, you'll have to go back to the PDF. If you write it correctly, right, that should be your output. 3 over 33, 1 over 11, which in decimal form is that, and then 33 over 3, 11 over 1, and then in decimal form. Right? So that should be your output. That's the goal, to get that output in the next hour. I recommend working with someone, right, to help work with your skills. This is all still time in. Questions? The file is, it's always below, right? So you have the PDF, and then below the PDF it'll say fraction.c. Right? You can download it, drag it into Cloud9, which will allow you to do stuff. Right? That will hopefully make it work. Right? And I'm obviously here to help people out as well. Make sure though before you leave you have assignment 3.
Can you help me with that?
I can. All right. Any other questions for the good of the class? No sign-in sheet today, so when you get done, enjoy your break. All right, and then come back after break. Don't go too crazy over there. What do you do? That's the construction. Yeah. 6 functions plus a constructor, so 7 in total. 7 functions. I was wrong.
Did I miss one?
I have 7.
That's yours.
1, 2, 3.
They're both correct. No, like
5, 6. 1, 2.
You're probably missing the constructor. Yeah, at the very top. Constructor.
Oh, okay, hold on. Let me just bring this so I don't forget. And then put it in the order that it's in.
Perfect.
Okay, I can fix that later. I need to open a terminal. So I typed it, but
Okay, so that's basically saying that since we've gotten stuff, your assignment 2 has changed, but it hasn't been committed. Yeah, there's your assignment 2. So we would get at it. We can just do it from here, get add, and then we get commit.
that makes me worried. Does that mean that I changed something on
in that file.
On GitHub, not here? No. So now I'm wondering what I turned in.
Well, I can show you the difference if I get push. Oh, I need other stuff there. Yeah, let's do this. Good pull origin.
So I need to do
master.
them all lost in here?
Yeah, but that's fine. We'll get it all set up. Try and never to make changes on GitHub. That's the key.
So then you pull the changes back here.
There we go. So now you got the 4 new files. So now if we log you into GitHub, we could look at the difference on the command line, but it just looks nicer. Let's do S.
Christy, it does. Oh, huh. You're right.
It's just was the same.
Yeah, you're right. What? Oh, you know what this probably is?
Yeah, probably is. Basically, you just can type whatever whenever you go get push. That's what you would type. So it's probably just this.
I've looked into it before, so I don't know what it says.
Oh, yeah, it's like that. No, without that. That's just your username.
Oh. I'm so used to gaming so many hours on my keyboard. Yeah.
Yay, we're in. Okay, so here's yours. This is the latest commit 2 minutes ago. If we look at it, it'll tell us this is what changed. This is what got removed. This is what added. Just one line.
Okay.
Which can fix that to say that.
That's almost
Yep. Alright, so there's your changes. Now, if we go here, you should have, there's assignment 3. That's what you're going to be writing in, and then 3B's after break, so just ignore it. Okay, unless you want to write them all over, right? Because your billboard or something. Yeah, okay. And here, you just Control X.
There you go. And there you go. And there you go. Sweet. Thank you.
You're welcome. This is where the class is.
Now I have to catch up so I can ask more questions.
So, this is where
Okay, how do you bring down the constructor? How do you write that one?
It would be the same
Is
as,
it fraction, colon, colon, fraction?
this would be the same name as the class, or the type, that's it.
all of your.
Oh, all of these need to be capital though, huh?
Yes, because the name of the type is capitalized.
So it works, right?
Okay, so remind me again what the stats is.
Oh, you made your other side, people do weird. Yeah, okay. Okay. We're gonna do it Monday. So we start anyway.
Oh, it's not capitalized, that's why. It's a bunch of bullshit. Nope, still fucked up.
This is where you.
Still fucked up.
Yeah, but so what happens is that you put fraction home colon on the type, you put it on. The void goes first. Void fraction home. You're gonna delete it, put it back on.
Are you supposed to add it?
Yeah. Well, okay, so you don't put it here. This says like it's a parameter. It's not a parameter. So think of this as a function. No, you don't have to. So it's just if basically if it's in the wrong order, if it's in the right order. Yeah, no. Right here. Really, we should do that. Oh. Yeah, because I made it private. Right, private just means that, private just means that. If you think about it, it is. So you just give it.
Okay, so at least it's running, so that's not wrong. How you doing on these?
Hold on. Okay, I got it working because you have in the double object, you're supposed to return the value of the fraction in a decimal. So you have to divide.
I'm not on double yet.
Oh, where are you at? Up fraction? The infraction? Okay, so.
Numerator. Is this where you just write the 1?
That's what I did. But then I realized you're supposed to assign it to the actual name of this variable. So you have to assign it to
It's
numerator.
this, but just 1, right? Because that's just a constructor. This is if you're getting just one parameter.
Yeah, you're right.
Got it. I just want to make sure I'm not like insane or super off track.
Wait a minute. Yeah, you're right. That first one up, that first one up there's, yeah.
Let's make sure this just does something.
Got it.
It's still running 0. Good.
We never wrote.
Where are you at?
I have to calculate the GCD.
Have you brought down all your stuff? Copy and pasted all your stuff yet? I would start with that. So go up to above into the class. So you have all of these. Go down where you see right above. Go right above private. All of those need to be brought down.
Oh, wait.
And then there's hidden ones inside private that you need to bring down. I brought all the
To remind us what is down, so I know which one, like this one,
up to you.
this one is an external value.
Get that started and switch those. That's the action of the actual assignment, is doing that itself. Does that make sense? So you can start with that. Does that make any sense at all?
No, I didn't. I saw the 24.
What the? 3/33 in decimal form, that's 0. I think I did something wrong here. Something's not right.
You have to do this one, I think. That's how you get the GC.
Yep, I haven't done that yet, but I got this. So 3/33 in decimal form is 0. So that's, what is that, 1/11? And then in 33 divided by 3 in decimal form, that's 11. Yeah.
Let's get fraction. What does he do in the out?
What are you looking at?
For this one, is this just putting that?
You have to assign it as a double. So the only way you can do that is if you return the value of the numerator divided by the denominator. Because
so return.
Yeah, and then you do numerator underscore divided by denominator underscore. Yeah, so when
you do that, right?
so return it in order for it,
yeah,
in order for it to come back as a double, you have to divide those.
You wrote this one, you wrote that one, we never wrote.
Output reduce.
Yeah.
So this is where you just see out.
You're gonna see out, like, get fraction, return the double, so you have to return the value, so not see out.
So this is where you see out the values, right?
Yeah. You see out numerator, and then I put a / so it looks like it's on top of it.
Oh shoot, I don't want that to be inverse. That's just a habit.
That's okay. Okay, time to do that GCD calculation.
output, you're not gonna divide it, you're gonna output the numerator, you're gonna output slash. That's in that, no, that's in that function. An output, you'll start, see how it's stuff. Yes, but the problem is numerator and integer.
The decimal form 11. Is that where you were? Is that where you're at too?
Yeah.
So like 1/2.
Yeah, because that's not right. You have to be able to calculate the GCD and stuff. Maybe I did it wrong. I don't know.
Which could you look at?
Something.
What? I don't know what to do inside this one though.
I don't either.
I think this needs to be done first before you can.
Yep.
Because this, I think you call.
You have to call
You call
GCD.
this inside that somewhere. I think.
Yep.
Okay. Let's look at the riddled code of this.
I'm stuck at else if. Because else if is that else if supposed to is in the parentheses supposed to be the while loop? Or just else?
This is just like this one, but it's numerator.
Hold on, let me read this. I just kind of want to read it in my head really quick. Okay, so function GCD small large if large.
Luke, I have a question. So with this pseudocode, when it says it says end if, not else if.
Are we even on the right track?
So end if meaning I just put an else and then do a while.
And if would be like for us a closing curly.
Oh, okay, yeah. So then I would just put a while loop right after that, or put an else.
A while loop.
Okay.
I'm getting.
Yeah, that's good.
So I'm doing my.
So you could
spots,
keep
right?
you could keep working, or you could notice that this is actually supposed to be 0.9 something.
Right. So I haven't touched this yet, which means that I can't do this until this is done, right?
But this answers
So I'm doing something wrong.
in your get function.
Like get.
So here's right. Anytime you ever divide, you have to think in your head, what am I dividing? Numerator is a what? What type?
Int.
And denominator is a int divided by an int gives me a
Double.
Right? No, it doesn't give me a
Or an
double. It gives me a double, right? So like 1/2 isn't 0.5, it's 0.
Right.
So you need to make one or the other be a double in order for it to work.
So we have to reassign one of them as a double?
But you don't do that, you typecast. So if you look at lecture 4,
Oh, okay. Yeah. Got it.
and you look at typecasts, that's where I would recommend you take a look at how we static cast. We've done this before.
Yeah.
This has all happened before.
Yeah, but we only so many
And it
cool
will happen
things
again.
there.
Oh my god.
What is that from?
That battle started last set, and it's got a really awful ending to go with that line.
Okay. So.
In the nutshell.
So that works, that works.
My Cloud9 just crashed. Fuck. I have to reload the page. Yep. Documentation and server status is down. Oh, came back.
Makes sense to me.
Uh-oh. I just deleted all my progress. Okay, great.
I mean, that works. You can static cast would be better. We don't have to do each one.
So you just have to do one of them, right?
Yeah, as long as one of them is double.
So all you have to do is type that, right?
Yeah, but then you have to change the.
No. Watch.
So this here, you'll notice that this function GCD small y, which looks a lot like GCD.
Where did it go? Okay, here. Watch. I
Okay.
think you just do stat,
Yes. Yep.
static cast denom.
But I've always thought about it.
Oh wait, no. You do static cast double
Yeah. Then you assign that to denominator.
Over
double, and then there's another thing you write right after this.
But it's, right, it's gonna return
Parentheses,
right,
the variable. Now compile and see what happens.
You
don't mind if I write that down?
Hey, starts right here.
If you like this correctly, you could.
So basically, the whole idea here is you need to put the class name in front of everything with with colons, and then you add your curly brackets. Next step is to fill them in with the stuff you need done. Does that make sense? And remember how the last thing he showed us was some of them have one parameter, some of them have two, some of them have none, one is a constructor, so it's default values. Those are all the things you're entering in here.
That you're CIing, but in your else. You're still need the lessons. See out 2 lessons. So that's that.
Getting an error. Oh, I'm missing a curly brace somewhere. Or a semicolon. Yep, it's right there. We just delete that real quick and then try it.
Did you do the static casting?
Mm-hmm. Yep. In decimal form, that would be 0.090991. 33 divided by 3 in decimal form would be 11. I think we're like 95% done.
Okay, I need this to be able to be read
It's still
next to it.
Now I just have to define GCD, which is going to be really fun because shite. Okay. If small, no, large is less than
But
small.
large isn't something saved yet.
Yes, it is. It's right there. It's declared right here.
Oh shit, that's awesome. Okay,
Yeah.
I can write that.
That's your attribute.
Thank you.
So.
Do you have to say int when you say if? No, right?
Mm-mm. No.
Is that where you assign the values of small and large to denom and the numerator?
Yeah.
Is that how you're swapping them? Large
Yeah,
equals
you,
denominator and
No, large equals small equals large. That's swapping.
well, no. If large is greater than small,
Less
large
than.
has to equal.
That says less than.
Okay, if large is less than small, flip them so large will equal
Small, and small will equal large. Yeah, that's exactly what I did. See?
I'm saying just assign it to.
That's what I did. That's what I did. I just swapped.
No. I'm thinking of skipping this step and just putting it where I want it.
That could work.
But I think that what I'm thinking of is what you do in this. Oops, sorry, I forget your state.
Yeah, that's.
You get what I'm saying?
Yeah.
In my head, I'm.
Yeah, in the output reduce, you assign the value of large and small, but you wanna define GCD first.
Always take the external.
I'm just gonna compile this and see what happens. Yep, something happens. There is an expected semicolon. Oh, there it is. Got it. Okay, now I defined what the GCD was, but now I have to do the output reduced function. Something in there.
Okay, so let me read this one. So if large is less than small,
You want to put the fraction up.
large equals small, small equals large. And then friend if blah blah blah.
No, that you don't do an if. End if means close bracket. So you do a while loop completely separate from the if statement.
That's what I'm trying to decipher.
Yeah.
Okay.
Yeah, you do a while loop, then
While
large is not equal to 0. So not equal is, I think, exclamation point equals.
yeah, but you shouldn't write it like that. There's another way you can write that, right?
Yeah, you put large exclamation point
No,
equals.
I understand that that's
Oh.
how it is, but he said that that's bad practice. Do you get what I'm saying?
There's another way to make it not equal to 0?
That was almost done. Numerator is an integer.
I don't think so.
Integer divided by multiplication.
Why can't you just say while large
greater
Oh, yeah,
than zero.
yes, yeah. Or
large less than zero, because that makes it where it can't be zero, but it can be anything above or below it,
yeah, you could do that.
right?
Yeah. Or you could do it the other way.
Whoa.
I just did it the other way.
In your case, you need a static cap.
That would work too, yes. And then you do the curlies, and then you put a semicolon after it.
Right.
You should do that now before you forget. Yeah, don't forget that.
So that means that you forgot to return hypothesis. So line 90. It all used to be double.
10th?
So that's just the double.
You have to assign a new variable called temp, so you have to put the integer. It needs to be an integer.
It doesn't have it here.
I know, but this is a different way of writing it, so you have, in C++, you have to assign it using integer.
Got it.
Yeah.
Got it.
I'm just waiting until I figure out what output reduced I have to do there.
Small mod large.
So the structure set right now. And
It's an output function that will output the reduced fraction.
But what happens is when I look for an investment form, right, basically it's no garbage value. Somebody's just
Oh no, I knew I did something wrong. Okay.
Hold on, let me try to
Hey
run.
Daniel, you at output reduced yet? No?
What? Oh, I can't type.
Some.
You'll fill in what it does, but it's good just
Wait,
to set
is that the right line?
Yeah, it's the right line.
122. No. This one.
Oh, you spelled them both wrong.
No, I just said. I was
Oh.
like, wait, that wasn't the one.
Okay, now you have to
Now I have
output
to
reduce.
I have to put this in here. I just wanted to make sure that this didn't ruin anything.
So
He had a question though, hold on, because he's behind us. What? You're just putting them to the
those two.
What you do is default them to the value so that they have to put.
You do that for all six, and then I would just try
So
to.
you can say that this
Then
is assigned
you
whatever
could look
the
at
value
what
is. That's kind of like forcing them to write it. Yeah, so you're right. Your zeros need to be this number.
But first, you kind of have to get all of them set up
Does that make sense?
before you actually start writing.
Like, you're not changing anything. You're saying this gets assigned that. These are different because that's an underscore. So you're getting this.
So at output reduce, you're gonna output numerator.
No,
Just like that.
no zero.
But when you output numerator, it's
Well, shit.
gonna be the reduce fraction, which is divided by. You have to call.
This is your clue of what you're assigning it. See, you get what I'm trying to tell you? They're different because this is an underscore. That's your attribute.
So then you're gonna find the GCD or what? Numerator.
And you're kind of going to be like feeling repetitive as you go down. That's your clue, kind of what you're writing in there. Does that make sense? Like I wanted to have these, but also so I'm trying to help. I'm trying not to just throw it at you without you learn. You get what I'm saying? Like, I'll help if you need. Be like, just tell me and just say that. You'll retain it better, right? Because then you're not lost. Okay, now I need to do my output. Is this where you're doing C out?
Yeah, hold on a second.
Swap is the idea that if I have X,
Oh, okay, something happened.
and this has 1, and that has 2, right? X needs to become 2. And the way we do it is.
We're doing something wrong.
No, what we have to do is we have to take the output and use that as the large and small numbers.
We need to create a third one.
A
third what?
Look, we're missing a step in our
Now that
things.
you basically duplicated X's value, because X can have so then Y.
Well, that's exactly what we did.
Well, no, we just did this crisscross. We didn't store large somewhere, so now they're both the same value. So large equals.
Or we could just say large equals small. And that's it, if they were done, right?
No.
Temp was declared in a local, temp is a local variable.
I know, but you can use it because it's in the fraction. It's in this function.
I know, but it's declared in this while loop, so it's local. So you have to use it in the while loop.
So if we're having a swap, that means we have to create that temp variable again.
Right, you can't,
Twice.
the pseudo just says temp, but.
Can you
So you have to
create?
You have to create it again. So we have to make it
So
again.
treat that function like main, right? If I want a temp variable, just int temp in the function.
But it's already in the while loop, so we use a different name.
Right, or just int temp before the if in the while, and you can use the same thing.
And just reassign it the percent, the mod.
Oh, so you would declare it way before all this happens.
Yeah.
Mhm.
And to get back to the function,
Temp equals.
so get back to the
So it wouldn't just equal whatever.
Do you need it to equal anything? Because you don't want it to be garbage, right?
You can declare int temp. Once you declare it, you can set it to whatever you want after that.
I understand that, but I'm
It
asking,
starts
do
off-
we
it's-
need to set it to anything?
No, because you're assigning it here.
Okay.
Yeah, if you open it up.
So large. Oh, okay. So then we have to do temp equals small, and then large equals temp, small equals large, right?
Wait, hold on, repeat that.
Okay, so first we want to save the small variable.
Yeah, so
So
it's
we're
stored
gonna
in
say
temp.
temp equals small.
Yep. So it's
So
stored.
then we want to say large equals small as well,
Okay.
and then we can say small equals large.
Okay, that's what I did.
Right. But you need to do them reverse.
No, I just did that already. So
So to swap them, okay, hold on. So we have large. So we have temp is nothing, large is small, right? These are our boxes. Okay. So we're going to take largest value, store it in the temp. So now these have the same value.
You don't want all of it, right? You just want static cast.
Mhm.
And then we're going to go and we're going to take small's value.
So get rid of double.
And get largest value. Wait, no. Then we need to reassign largest value to small.
So that looks like it will work, because if you're storing the value of small, right, and you assign large to small, so that means the
And then
value.
small equals temp's value, because if you do large equals small, then they're both the same value. So this needs to be large equals temp.
That should be numerator.
Yeah.
Wait,
Would it?
no, I'm backwards.
Temp is already saved, so you don't need to. You don't need to declare it again. Just small equals large would be.
No, this needs to be temp equals large. And then large equals small.
Numerator underscore.
I think the original way you had it was okay.
We'll get those working and then we'll.
Because
So backwards.
no, look what I
There
did.
needs to be 4 things, right?
No, you need a third variable just to save one value. So that's what I did, right? I said temp equals small, so I saved the value of small.
I need to like see it.
And then I assigned large to small, which means the value of large has changed to small. But then the value of small has been changed to large, but the original value of small has been assigned to temp.
Well,
You don't need breaks at the end of it.
oh, well,
So this
it's actually supposed to break because these are fail states. So either it's a draw or if the player is killed.
I'm okay with
So that would be so temp
Okay, so
equals 1.
the better way instead of a break is that your while condition is what breaks.
yeah,
Here you would set a variable that goes over. Right? We have both our children.
yeah.
And you would loop while both our children.
Then we're going to then assign
You loop while or right or player is
Wait,
killed.
so it would be while,
While both are killed.
And that means players 2 is equals 2 and then temp equals 1 still. Then we're going to
You know that return at the end? That stores the value of small. So
it's gonna loop while all those are false,
well,
right?
it puts it in the
If any of them
GCD.
become true, then that statement is false, and when you and falses together, you get false, and that's what enters.
smallest.
Ooh,
So, okay,
that's a lot of errors.
So temp equals large, large equals small, small equals temp. Done.
Yeah, so that's good.
Boom, done.
Because, so, yeah, so like every time you go to main.
Now the output reduced function has to
Now
output
that's where I'm
something.
at too.
Has to output something.
So we just finished.
Oh, I'm just gonna say output small.
My fraction.
Nope, doesn't
No,
exist.
look in here, look in here. Let's see if there's a clue in here. Does he call GCD in here? No.
No, not yet.
The value of small has been stored.
But we need to assign small and large to the denominator and the numerator. They're not connected to this at all.
Yeah, but you know how you do that? You output GCD, right? And since the GCD accepts 2 parameters, the small number is 3 and the large number is 33. Like that. They accept those parameters, so now you've assigned small and large, but when you run the program, it's not running correctly. It says 3 over 33 is 3, and in decimal form, that's something. It's not
I
reduced.
don't think that that's how you do that. I'm gonna try it with you.
That's probably not right, but that's the only thing I can think of. What the? I think Cloud9 crashed. You got to refresh the paging. Yeah.
I didn't crash.
You sure?
Still running.
I know it's running, but it's not. There's a
I can
bug
delete
somewhere.
that.
There's a bug somewhere.
It's fine. Oh, I just deleted it and go back.
What? I can run mine just fine.
Oh, yeah, no, it would be.
Yeah, let's get Luke over here.
Yeah.
I'm out of ideas. Wait a minute. Wait. 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 I'm on to something.
I think small and large need to be assigned to.
I almost got it. Hold on. Wait. Damn it. It didn't work.
Shh. I already did all that. I just need to output those. I need to output what this does.
Yeah, you got that far?
No, I've gotten there, but like, I think that these two need to be connected to these two.
Just trying to see how you what results do happens.
Has the value of small been defined anywhere else? Has it been defined in the class?
Same
Let
time.
me see. Lucas. George Lucas, please help me.
So I'm just putting this code in, because basically, yeah, we're using the same code. So when you're saying, how do I get the GCD? Well, the GCD is wrapped up in a function, right? And it's a function that allows
What if I want to output the parameter that has been returned into the default parameter?
here, right? It's supposed to be a numerator over the GCD, right? Well, the GCD is wrapped up in GCD, right? So I'm calling this function, but this function takes what? Means that when I call it, how do it more simply. Well, what am I trying to find in not say what to do inside? Right. What's our score right now? What variable? These are the variables in the GCD function, but they don't do this now. Right? But in this function, the only variables I have are attributes, which function means. If I do that, you have to do if on the other way to do that, you're saying, right here, I output 33 slash. Here, I'm saying, take that 33 divide that.
It's not assigned, so it doesn't know what it's doing. So that's why.
Because this here, small margin. This.
Now we
get the 3 over 33, the 3 is going to be small. That will just whatever you want it to be, right? Think of it as a value, right? It's the value that you're trying to define.
So there needs to be a ton of parentheses in this, right?
Yep. Quite a few. I'm gonna do exactly what he said. So let me see.
Right, that's how you call it, right? So you're seeing that that's the value you're getting, but you have to take that value and you have to take the numerator
Running.
and divide it by that.
Compiling. Got it.
Hold on.
So that's because it looks like it's coming out at 0.
Oh, I messed up somewhere. Something messed up.
So let's look. 10. If large is less than small, 10 becomes large, large becomes small, small becomes 10. That just might be it. Yeah, that was coming back. Okay. And then while large doesn't equal 0, 10 equals small, not large, small. Oh, and then at the end, you must still return small after the loop. Yeah, there was a return small. So there's the 1, right? Which is the numerator.
All I did was get 3 over 33.
The slash.
Okay, hold on.
As a character.
Gotta switch these around real quick.
Kind of like what you did here. Oh, so you don't even see this. Yeah, limiting 3. Right. So the 3 is the GCD. That's good. Right. So the 3 is coming down here.
1 over 11. Why is it mixed? Why is it moving around like that? Oh, there it is. Okay, everything's right except that. Except one.
Is that great? You get done with these labs and you're like, I don't know if
Why
I
want to be done with this?
but I got the right answers.
Son of a bitch. Hey, you did it right. Maybe try this. Put a space in between that. There. Damn it. There's too many parentheses. Are you sure?
Because there's one around the whole thing.
I don't have that. I don't have that many parentheses.
I'll erase the outermost ones. It's not even giving me.
No, because look at mine. I don't even have parentheses in there. So delete that parenthesis right there, and delete this other one on the very end. Yeah, that one and the one on the very end. Now try it.
Okay.
Wait a minute. Okay. Numerator underscore divided by GCD. Okay, and then divided by. No. You don't divide it again. You output a string that's a forward slash.
Hopefully not beyond.
We need help too.
So delete that forward slash. Now put a set of, whatever, and make a string that's a forward slash. So in quotations, put a forward slash.
Just like you did up here.
Yeah.
You're doing the same thing. You're just this time.
People talk about strings.
Yeah.
And then you put another set of, arrows.
Well, you maybe did a string.
And then try it.
Right? Numerator slash denominator. Slash.
What am I missing?
Oh my god.
Figure out.
Yeah, Luke.
It's not outputting anything, it's just doing that.
What did you do?
Also, I didn't want to write that as a not 0. I didn't want that as not 0, so I wrote it like that.
Yeah, but that's always true. Large greater than 0 or large less than 0 is probably not getting that. Just write it how it said to write it.
But you said that's bad practice.
Well, not Euclid said to write it this way, so write it this way.
I don't live.
He's a lot
on Euclid
smarter.
Avenue
He's a
anymore.
lot smarter than me. I wonder if that's a picture. That's gotta be a picture. There he is.
Oh,
Look when he died.
Jesus.
Beforehand.
Yeah.
Did he die? 285 BC? Oh my god.
This might just be broken.
Yeah, that's what I'm saying. Like, you might just have to refresh the page.
Yeah. Now you're stuck in a loop somewhere.
So look, I'm having a tiny problem with my output.
Give me 1 sec.
Okay.
Well, large doesn't equal 0. Int temp is small mod large. Small equals large. Large equals small. What else was supposed to be? I don't remember.
I have it open. I had it open somewhere. Oh, it's in another page. Just do the. Yeah.
Large equals 10. There, shrimp my loop.
Oops.
Those look really nice.
Oh shit.
Yeah, see, I'm having a tiny problem. So when I do the output, everything's correct except 1/0.
Which probably means that. Alright, let's look.
I'm assuming it's probably this somewhere.
It's probably your swap. If large, because the swap only happens the second time. If large is less than small, temp becomes small, then large gets overwritten with small value.
Yeah.
Now you're setting it overwrite small with large value, which is small. That should be temp.
Oh, small equals temp?
Small equals temp.
Oh.
Because that's what you store.
Oh, yeah.
Just want to look at it.
I still get 1/0.
This? This one? This is just outputting. This is so that you get to see this over this with that in the middle to show that. This?
There we go. Now I gotta do assignment 3A.
That's all it's in it. Oh, that's set D now. Void, fraction. This one? There's int fraction, GCD.
You're just going to
So much BS. Yeah, I messed up in my logic. I moved some of this around, and it gave me like 1/0, and I'm like, oh.
I knew you had it.
See, the value,
you were confusing me, and I needed to write it on the paper. So I knew there was
Yeah,
something.
you definitely fixed it when you wrote it down, because if you assign temp as large and you say large is small, then you have to reassign small to the other one.
Mm-hmm.
So that's why
you're trying to swap them. You must have.
Yeah.
In the logic you thought you were doing that,
I was,
but what you
I was
wrote
swapping
didn't
the
do
same
that.
values,
Yeah,
so
yeah.
it was just like, what?
Do that assignment
I'm gonna just see if I can get it started so that I know what I'm doing, so I don't go home and be like, fuck. I did it. Okay. 2:05 p.m. 10 minutes before it had to be due, or something like that. Oh wait, no, it's due at 11:59. Okay. Assessment 3A.
Did you forget where it said you should return 0?
Okay, the purpose of this
Did you
assignment,
read the
you
comp-
must code the following in style and documentation guidelines presented in class. Your program source code must be documented correctly. Your program source code must be neatly and considerably formatted. Program must provide the features described. Oh, you just have to make the stub functions. That's it.
Like the first quarter of what we just did.
So all you have to do is just copy and paste them and assign them and change them as functions. And then change them to...
You don't have to put any values in them, right?
No, you just have to change them to, what is it? Mutants and other ones, something like that. Mutators. Mutators and assessors, that's what you have to reassign them as. That's it. It's like 2 seconds. 2 seconds. Maybe even 5 seconds.
And then, yeah, copy.
Gotta put them below the. I think he wasn't kidding when it said it was that easy.
What's the name of the class? Distance?
Yes, so you just have to do all that, and there you go. Chanel. We did that so much that this is going to be too easy.
You didn't go into main and just see how fast. See, I got really if statements, I just said see out cast, right? Yeah, right. I don't know, what does it mean? What does it say now? You got Tyler? Yeah, what does it say? What does it say? Oh, I cast them all, but. Yeah, so you're not. Hey. So get commit space dash in.
I don't have mine saying pass anywhere.
No, this is the assignment, not the.
Oh, okay.
Oh,
It's a comment. You just say whatever. You want.
I was like, Dub, what? No.
Bullshit.
So every time that you commit, you're basically like packaging up the changes, right? So you're like basically imagine you have this box. And all the changes.
It's literally always asking is if you can change it to a function.
So what are you gonna write on the box? What's in the box? This would just be like adding file. Just imagine you're labeling that box.
Okay, so he didn't want to.
Let me compile it, see what happens.
The box is still gonna.
Your code exited with 0. Failed. Passed, failed.
So we
Okay.
need to do something to those?
Okay, so that's.
Yeah, I'm getting the same problem.
So
Yeah, you have to set them as mutators, I think. They get to set those as mutators, maybe. Or maybe not. Which one is it? Meters? Oh, it's an assessor. Ooh, that's right. What's the other one that's a mutator? Oh, that's already an assessor. Then why did it fail? Why did it fail?
So you have to check it.
Meters and get distance have failed.
I could pass in 10 and 5, right? Well, large isn't bigger than small, so this says, well, if large is small, right, 5 is less than 10, then small needs to become 5 and large.
So, okay, look, testing meters.
But
So
swap,
meters,
I grew up on
if meters equals 0, say pass. So right now, we need to change the value of meter, of 1.meters
So you
to
do
be
meter,
0.
so meters underscore equals 0.
Yes.
That's it. It's in the function distance, right? Or void.
Double distance?
Yeah, we set it to 0, right? So meters underscore equals 0. Let me run it and see if it passes. Yep.
What's the other one? Get distance.
Yeah, get
Does
distance.
it change automatically if that? So one more has failed. What's the function?
Here's main. So in main, when I say like set numerator and I pass in 33, then set numerator knows numerator values.
Double distance.
So these values,
Distance.
small and large can be any values, but if anytime I say GCD,
It needs to be inputted as M.
So would you make small?
You need to input the letter M. So I'll just say get distance equals M.
Because you don't say equal, you just pass M. And that's what makes it equal. So down here in output.
Well, no, distance has parameters. Care unit. So unit equals
So what does
M,
GCD take? It takes a number.
right?
In double distance? Are you assigning a value in double distance? Oh no, void distance.
Does that make sense? So
Wait,
this
no,
says
it's
go to
under
that
it. It's under
function,
it.
So it's double.
and whatever the
It's
values of
this
these
one.
are.
Void distance.
Void distance set distance.
That's the output, I think, in the output, right?
No, but the one that's failing is get distance.
I'm gonna return 0.
So, oh,
Yeah, there's 2 of them that return 0.
you're right.
We just changed the value to 0 on meters and it made it work too. I want to try it.
It passed. There we go. You just have to change. You have to say return meters underscore, right?
Return 0.
Return
What if
0.
you just change meters to 0?
I changed meter underscores to 0, so I say return
Well, you
meters
did more than what
underscore.
I asked you for. You didn't just write a stub function. You did more.
So is that good?
Alright, that works.
It probably works as long as they all say passed, right?
Well, kinda.
Distance meters.
Wait, why does it failed again? What? No. Okay, get.
I said return 0 and it still
Get
worked anyway.
distance. Oh, it's in here. Return.
So what do you think?
Zero.
Here, right?
Yep. You're done now. Finally. Okay, so do we? Oh, we have to get push, huh?
Yeah.
Let me just reload the page real quick.
What am I trying to find the GCD? Numerator and
What the hell did I just do? Okay, there it is.
Assuming you wrote the algorithm.
Get
That's
pish.
the assumption I'm making.
That's what I
Is that
said.
it?
Wait,
That's it, right? You just do push, put your username, password, and then you're done, right?
you have to push a certain file.
No, it just pushed everything.
Oh,
Counting objects, 15.
oh. Okay, I guess you're done.
You know what that means?
That's what we're supposed to do, and also we know it's just about
So you do the first part of what we did already, and then you just add return 0 to the ones that are failing. That's where you do the double colon, parentheses, or curly brackets, but in 2 of them you need to add return 0 to change the statements to true, so they produce pass. Produce pass. How do you turn in the slab again? You just download it, right? Yeah. You download project.
Yeah, I just uploaded it to.
Well, no, for the lab.
No,
for the lab.
For the lab, you have to upload the CPP file. The .cpp file needs to be uploaded.
How do you do that?
You go to the original. It's right there. You open this file, change it to the code that you wrote in Cloud 9.
No, I don't want to do that.
Or then that's, I don't know what to tell you.
No. Let's do this.
Assignment 3A was edited a minute ago. What the hell did I just do?
Oh, yeah.
Oh. I need to delete some stuff. Okay.
Before class got fired, I would be confused that. If I remember, of course.
Can you save it as a CPP here?
Yeah. There we go. I rewrote it. Got it.
There is each choice.
Yeah, let me get.
Wait, no! I have to do it this way.
Do what I want.
Which means you have to turn it on. Which I don't let you do. You can't do that.
So what do you open this way?
Hey, how do I open this? The CPP file.
Oh, edit with Notepad. Plus plus. That one right there.
Right?
And then you delete all that, and you paste the one you wrote in Cloud.
That's what this is.
So you copy that and paste it in the fraction.cpp file.
Okay, but how do I paste it in here? What do you even mean?
Hey, look.
Okay, so it's copy, but
Copy that.
right?
Now go to fraction.cpp. Now copy, and just highlight all that. Now press Control V. Done.
Now what do I do? Save
Then you
it?
save it, and then you take that file and upload it to Canvas. And then you're done forever. For the next week. Excuse me, can you unplug that laptop for me, please? Thank you. Sorry for the interruption. It's a lot of logic we gotta think about, you know? Think about the logic. 2:18, 3 minutes late.
I got clients. And I got
Oh, yeah. There's always time to out. There will always be time.
But there's not always